Something new has happened and we gotta talk about it. Hello and welcome to another Solana tutorial. Today we're gonna talk about the new Web3.js TP4. Yes, we have talked about the TP3 and I don't think a lot of things changed, but I feel like it is my responsibility as a Solana dev to really look at all of those technical previews and give feedback in case I can. Because the new Web3.js, that's what we're gonna use. And by we, I mean Solana devs. Like most Solana development will happen with that thing. So it would be really nice if that thing would be an easy to use and something that we all like kind of a framework. Of course, different people have different preferences or whatever. Nothing's gonna fit for everyone. I mean, also it's TypeScript. Some people just prefer their Rust and that's perfect too. But I still think the majority of people are gonna work with the Web3.js, and I do think that that transition from the Web3.js that we have right now to the new Web3.js it's gonna cause a lot of trouble and will just be a lot of effort for people to get used to, especially if there are things in there that are not intuitive. So I make it my mission to look into it and see if I find anything that I don't like and then raise awareness about it. Because right now is still a great time to bring in feedback, to come up with improvement suggestions, because the team will merge them in. Right now, it's still easy to change it. Once it's been released, like officially, not in the tech previews, then it's much more difficult because then any breaking change will need a major version update and you need to first deprecate things, because you always want to be backward compatible and whatever. For now, that's not relevant yet, so we can still change it a lot. On the other hand, that also means that for now, you probably don't want to use it productively yet because it can still change a lot. But I do recommend that you use it unproductively. For testing purposes. If you write a short little script, try it in a Web3.js just to get used to it a little bit. And if you find something that you don't like, that you can give feedback. So yeah, here we are again, looking into the newest tech preview of the Solana Web3.js. Let's go. Solana Web3. I wonder if that thing just moved to another repo, but I think no. Looks like we're in an active repo. Okay, cool. Apparently it's still in the Solana labs because I think the people who develop it also went to Ansa. But anyway, not important. What is important? Here, the new Web3.js Tech Preview 4. This version of the Tech Preview fixes a bug with a default RPC transport. Adds a utility that you can use to get an estimate of transaction message compute, and introduces Solana React hooks for interacting with a wallet standard, a wallet adapter. So the wallet standard wallets. Finally, it supports the wallet adapter, which is somewhat relevant if you want to, build a dApp that interacts with wallets, right? For now, we've just been writing scripts, but maybe today we'll have a look at how that thing works and how we can actually work with a wallet, like create an actual website that interacts with browser extension wallets. For an example, see the example application. So what else has changed? Wow, that's actually quite some changes. So let's prep and get the new Web3.js. Just in case I have a nodes folder somewhere else, I'll create the node modules folder in here, and then I run the npm install just to make sure it's installing it in here locally in this very folder and it doesn't mess up with my other npm stuff. There we go. Wonderful. So here we should have Web3 just to check what's in here. The account base, that looks like the new Web3.js. Don't know if it's the TP4, but we will see. So what changed in the TP4? Let's go through a few of those. I'll skim through that and see if there's something where I'm like, oh, this is interesting, or this is important. Sign and send transaction message with signers automatically asserts that the provided transaction message contains a single sending signer. Allow creating key pairs and keys from read-only uint8 array. That's just another type. Minor changes I don't think I'm so interested in. It's great that it can do that now. Edit more configurations. Development mode error, message printer no longer fatal on Safari. Great. If it doesn't fatal, that's good. But yeah, all just, you know, basically bug fixes. Nothing really changed in the spec. Yeah, bug fix, bug fix, bug fix. Simulate with maximum compute instead of the max U32, which also makes sense. That's maybe interesting. Created a utility function to estimate the compute unit consumption of a transaction message. That can be pretty helpful, I guess, because you don't even need to simulate then, right? Or does that simulate? Probably does need to simulate, because how can you know otherwise? Yeah, we talked about that. Of course, this simulation is just a simulation, and you might add a multiplier or some constant CUs, because obviously it might be different. But yeah, so basically, I guess this thing wraps a simulation and gets the compute. So that's something I want to have a look at. Then that's also interesting. React hooks. You can get the inner instructions because we allowed this parameter. That's something that RPC needs to support though, but I think they do. Just the Web3.js didn't have it before. Okay. I mean, so far so good. So there are a few things that I want to look at. For one, this estimate, because that's something that could be super helpful. In Solana program compute budget. That's one. Then I also want to have a look at if they fixed the thing that I found in one of my previous videos where the system program with seeds instructions didn't work, didn't have the right padding or offset or whatever in the instruction data. And then we're going to have a look at the React stuff, because that's probably the most important change in this TP4, that the wallet adapter is included. All right, so we got plenty of stuff to do. Let's get started. All right, so as a recap, how do you build a transaction in the new Web3.js? This is just something that you need to get used to. And I would like to copy it from my previous one, but no, we take the challenge to actually try it from scratch. So also gonna import from Solana programs. I think the system program is in here. Is program error? No, that's not what I want. Oh, do I need to import that separately? Oh yeah, that's what I probably need to do. How was it called? Solana system? Was it that? Nope. What was it called? Oh, Solana dash program system. That's it. Program system. That was it. Oh, wait. I see. I'm getting dependency issues now. So apparently we have the preview 4, but this one has still the preview 3. That's why I can't install that, damn it. I mean, I can force it and be like, it's fine. We can try. Potentially it doesn't work then, but maybe it does. We'll see. But see, then that part is still basically from the previous. Therefore, that bug might not have gotten fixed. So create account with seed instruction might still not be the thing that we want. Last published 16 days ago though. I mean, that could have also been updated since then. When did I make that video? Whatever, no, doesn't matter. Let's not get stuck here. Okay, so how do we create a transaction? Well, I'm just gonna get the instruction first. Parameters for that are, I'm just gonna borrow a bit of code that I have somewhere else. You can create the signer. So those basically are the same things. That's my key pair. That's my signer. But essentially they do the same. They're like, it's just a different type. And then my seed, gonna create it with my key pair address. For which program? Yeah, why not for the system program? It doesn't matter. Then we get this account. So that's now the address, but I can't call it address for reasons, because address is now a function that gives me an address of something and checks that it's a valid address. But anyway, what were we doing? Right, we have the account, and then we can create such an instruction. So that account will be the new account. I need to give you the base account. That's the signer. So I need to give you the signer, I think. Payer is again my signer. I assign it to the system program. I give you the seed and amount and space. It's the 0.8. Just gonna do this. Should probably not hard code that in here, but actually request it. I'm just gonna create an empty account. That's what I'm doing. So the payer needs to be a transaction signer. Okay. And that should give me the instruction. And then with the instruction, we remember how to build transactions. Nope. There was something with this pipe, right? Give me that pipe. Let me pipe. I'm a plumber. Pipe. There you go. We get it from Solana Web 3. Yeah, oh yeah, that's the fun between 1 and 11 arguments. Yeah, so there was this create transaction message, I guess, in the version 0. Why not? We can also say legacy. That's the, like this. Legacy, that's the alternative. But why not? Let's do a version transaction. So that's number 1. We create a transaction and then we add signers to instruction. No, I'm not like, I don't know by heart yet how that works. Something with add or append. Oh, it was append and prepend, right? Yeah, append transaction message instruction or instructions. Here we do one instruction to the transaction. Oh yeah, and then of course the transaction goes here. From this we get this and then we put it in here again to get this. That's how it works. And then we need to sign it. So again, the transaction, and you just need to get used to how that's written and then it'll be fine. Something with signers, sign transaction message with signers. Wait, there was also something new. The sign and send transaction message with signers. I don't know what that means. Let's use this function. Gives me a promise. So I can also just do that in the pipe. Property fee payer is missing. So if I have the transaction coming in like this here, then you complain that fee payer is missing. Right. So we need something like set transaction fee payer or fee payer signer. This thing takes the fee payer as an address and the fee payer signer takes the fee payer as a transaction signer. I have it as a transaction signer, so I give it to you as the signer and here the transaction. Okay, now better. No, but you're not complaining that the fee payer is not here. It's the lifetime constraint that is not here. So that's either we need a durable nonce or we need a block hash. Fair enough. Let's get you a block hash. So once you start working with it and understand what the layout or whatever is, that's actually not so bad. Like the error messages are not so bad. Like I know from just, you know, seeing what's wrong here, I kind of get an idea of what I'm missing. And then by just, you know, typing something like that, I find there, set transaction message lifetime using block hash. I find the right functions without looking up what the actual names for that is. Just by having, you know, I could have also just tried lifetime. Anyway, so what do you take? You take block hash and last valid block height. That stuff we should again get from an RPC. So we will need an RPC again. How did that work again? Create RPC. All right, create Solana RPC. That was it. And then that thing should have a get latest block hash, commitment and minimum slot. But I don't need to specify any of that. I do want to specify commitment though. And that will give me an response. Wait, no, I also need to send that, right? Hold on. Yeah, I need to send that. This response, it should have a value, or I just directly get the value from here. Then give me the value. And then I have the block hash. And the block hash I put in here into that transaction. And then hopefully it doesn't complain here anymore because that thing now has a fee payer and a lifetime. Wonderful. Looks good to me. And that thing should actually also already send it. Sign and send it. Cool. What key pair are we using? Something for the TP4. TP44. Well, we're not that far, but anyway, gonna use this. Airdrop ourselves some sol, just so we have something to work with. And then we check if that actually works. So we ts node this tp4.ts. It does not work. Await is only valid. Yeah, of course. Of course. Let's do a function then. Decode I mean, I kind of like this, but also I kind of don't like it. Experimental warning. No transaction sending signer was identified. Transaction with single sending signer transaction. So, okay. You, I guess, are complaining. Well, yeah, that's true. Hold on. I just gave you the transaction, not the signer. And send transaction takes what exactly? So apparently setting the transaction message fee payer signer is not enough. So this part here is still a bit confusing. Maybe somebody needs to properly explain that to me, how that like work. There seem to be different kind of signers, the message signers, the transaction signers, and the transaction sending signer. Are a bit confusing. Checks whether the provided value implements the transaction sending signer interface. Yes, that is probably called and then tells me that it's not a transaction sending signer. You take what? I'm just logging if my signer is a transaction sending signer. I mean, since I'm not depending on the transaction, I could do that outside, but whatever. It is not. How can I make my signer a transaction sending signer? I feel like I should be able to give you a signer as well, but I don't. Using any signers that may be stored in the iAccount signer meta. Let's see what happens if I add the signers to a transaction message, because that is the transaction message. An array with my signer and the message. I shouldn't call the message tx, that is confusing. Because we're not talking about a transaction, we're talking about the message of a transaction. The transaction also contains signatures, which that thing certainly doesn't. But anyway, here it then creates that signature and directly sends it already. Let's see. So we're still not a transaction sending signer. Somebody explain that to me, please. I take it back of this thing being intuitive. It's not. Probably if you get used to it and you see a ton of examples doing the exact same thing, you will figure it out. But just having the Web3.js like this is like, I have no idea. Like, this is not intuitive on why that thing is not a transaction sender signer that it requires here. How do I make it a transaction sender signer? I want to sign with that. I can sign with that because it's literally a signer. Wait, what type is that? Key pair signer. Okay, hold on. To be a transaction sending signer, is that even a type? Aha. So a transaction sending signer is something that has an address and a function to sign and send transactions, which, fair enough, makes sense. How do I get that then? I mean, I could build this manually. I just don't think that that's what I should do. Let's not do it like that. Sign transaction message with signers. It just takes the transaction. Let's see if that thing complains. And then we should have a signed transaction. And we use the send and confirm. Again, build a send and confirm from the factory. Let's see if that would work. Yep. Look, I can do. Wow. But hey, that means that they fixed it, because if that transaction really went through, then that means that the system program create, which, oh wait, I'm on mainnet, that's there, DevNet. It did go through. I can do the create with seeds, and it does use, there, it does use the right padding for the seed, which there we had the issue last time. It only used 4 when it needs to use 8 bytes. So that's cool. And then those are the 4 bytes of the seed. And okay, cool. So they did fix that. That's great. That's the one thing that I wanted to check. The other thing that we wanted to check was how that this estimate works. But actually before, I would really still like to understand how I can use this. Now that I messed with it so much, I kind of want to get that there. What would that need? Or maybe the sign and send message, maybe that's for the React stuff where the hook is called, where we have a hook into the wallet adapter. That could be that I shouldn't actually use that with an actual key pair, but that should be just for, you know, wallet extension kind of stuff. But even then, I would like to understand how I can still mock a key pair in there. And to not waste too much of my own time and yours, I'm gonna check out this example and see if I find it there. Because if we, if we use it, then yeah, it's a React thing. If we use that, then we've set that as the transaction sending signer. There we go. Right, so if we use React and we have the transaction sending signer set with the use, then we can use this function to call that hook, which then signs the message with the extension. That makes sense. So in a script like this, it doesn't really make sense. But there is a create mock transaction sending signer. Right, okay, it just mocks it with an address, and the sign and send transactions is just a test function. I have promises for signature bytes and I need a promise for signature bytes. Oh, this is so annoying. Why am I even attempting to do this? This is stupid. So last try. Let's go back to that just one. I mean, this is just spoofing anyway. It's okay. Whatever, I think I don't manage. I don't know how to TypeScript, and I don't think it's important. Never mind then. Never mind. I'm not supposed to use it like that anyway. I just tried to mock such that I can then use this. But that's more important for when we use React anyway. So what else do we want to look at? This estimate. Okay, can we estimate get compute unit estimate for transaction message? Factory. We grab that real quick. So that's again a factory, which again needs the RPC. I can give you that. And then we get a, well, should we call it that? Weird name, but we'll call it that. It's not long at all, like not like I need more space on my screen to actually show this. And then we can call it with our transaction message. And you also want a config. Oh, here goes the transaction message. Wait, what's this then? It again a transaction message in the config? What? Wait, how is that used? Just a transaction message. It does not need a it doesn't need a config. This is weird. Let's make that the signed transaction. And before just the message, here we put the message. That should be the same thing now. Okay, that's fine, but then transaction message, you also want the message. Is that how I need to put it? Why? Somebody explain me why I need to put the message here and here. That's weird. Somebody explained it to me to also use correct grammar. That's not correct grammar. Anyway, so that should give us, if it works, an estimate. And for now, I'll just log that estimate. I'm not using any priority fees in this transaction anyway, so doesn't matter. But I would then use this estimate to, you know, set an appropriate amount of compute units for my transaction, which you can learn how to do, you know, in other videos that I did on that topic. Let's see. I would expect something like 150 compute units because it's one system program instruction. But what we get is an error for already in use. Yes, because we already created that account. Did we get the... Oh, this is a promise that we get back. Okay, it's awaited then. Maybe we get... Yeah, there. But there we get the 150. It's the estimate that we get from this. And then also, when we simulate it again, where it's then failing, we also get the 150 for, again, the same amount of compute. Because we already used the seeds before, you know, if I would use another seed, then I wouldn't get that problem. And it would just, you know, work. Oh, now I have 300. Why? Why did you now estimate 300? 150. That's odd. Lol, why did my estimate give me 300? If I do it again, it gives me 150 again. Do I want to know what it does? I mean, it's probably not so relevant, but maybe there is a bug again. Who knows? Do I want to analyze what that does? Ensure that the message has a set that's why. Ensure that the message has a set compute limit instruction. The set compute limit instruction itself consumes compute units, so it must be included in the simulation. That's why. But that's weird that it one time includes that and one time does not. I mean, it makes sense that it says 300 because it adds this instruction, but then why did it not add that instruction if I run it the second time? Because it failed? No, that doesn't make sense. Okay, I don't think it's too important to get into the details of that. I guess it's enough for us to note that for working transactions, like if I have seed 3 here, and maybe also let's not actually send it, then it will add the compute budget instruction for setting the compute budget. And that again is an instruction, and we know that that takes 150 compute. Therefore, it's not just our 150, it's the 300 in total. And if I run that again, then it will again give me 300. Don't ask me why for failing transactions it doesn't do that or doesn't kicker or whatever. Don't even want to know. At that point, I'm like, whatever. But yeah, it makes sense, because as soon as you then actually add the instruction to set the compute limit, to set the micro lamperts, or wait, what does it add? Set compute limit. You should probably add both. You should add the set compute limit and set the price. With both of that, with this instruction, it will get you to 450. And again, you should also have a buffer to, you know, allow a bit more, unless you know that your transaction looks exactly like that, then you can be that exact, but you know, whatever. We're really talking about tiny amounts of compute. But again, here I'm trying to really analyze like in depth, because maybe that is just an error of that function or of that factory that then builds me that function. But at the same time, I don't want to analyze it too much. I'm just testing here. And if Stephen Lucier or Loris or any of the people working on the Web3.js decide that this is worth investigating, then please do so. I'll stop here. I need to. I'm already recording for 2 hours again. I'm like, I gotta get going, because the last thing that we still want to look into, and that's the big thing, is all of that React stuff. And I think because we are already so far in, I'm just gonna look at that example code and not try to build it all from scratch myself. That I will do maybe once this is officially released, build a proper application, because for now it still changes. So it's not too important to get all the details, just to get an overview and see if there's conceptually something that I would really love to change, like how it works, because that is what will be difficult to change otherwise once it already got released. The tiny bugs and stuff, that can always, you know, that will always be able to be just quickly fixed. But, you know, major like breaking changes, that is the difficult parts. I mean, one thing that I do want to say is that I'm not particularly happy with those long function names. Do I have better suggestions? Not really. I'm happy that you lowered some to just, you know, transaction message, signature, and address. That's usable. But some of that stuff is just get compute unit estimate for transaction message factory. It says exactly what it does, and that's great. Speakable names, wonderful. But at the same time, what would be better for me? I don't know. I'm just realizing that more than the old Web3.js, the names of this are pretty long. But what I do want to say is very positive, is that most of the functions have in here an object that they take. Like here also the config for this. This is in an object. Here, this is in an object. Here, the parameters for this instruction is in an object, which might make it a bit more difficult to work with, because you always, you know, need to create an object in here and you don't have the parameters. But it's way nicer in case something changes in the future, that you can just change this object or the type of this object, and you don't need to, you know, change the parameters, so the signature of the function. It doesn't change what the function looks like. So it's never really a breaking change on that thing. We don't need to deprecate a function with certain parameters. We can keep the same function, but just update the type that it takes, which is easier, way easier. So that's good. Anyway, so React. Whew, I think we're just gonna look at this, no? Oh, that's the app itself. Cool. Can I get this locally, please? Because I do want to look what's behind that. Okay. Check out TP4 hex. Yeah, there we go. Now I'm hopefully at the thing where I want to be. Gonna open this. Where was it? In examples, React app. Just gonna open this React app. Yeah, why not? I trust you. So npm install. Do I have npm? I can just use npm to install it. Try again. There we go. Done in 23 seconds. Wonderful. Ignore the warnings. Can't be so bad. Whatever that does, compile whatever. Turbo compile them. There we go. And then pnpm def, which I'm assuming starts me a server. Yep. At this port. Wonderful. Now we have that locally. Perfect. So now we can connect our wallet again as we're used to. Hot damn. There we go. And we have one sol. Cool. I like it. Sign message. And then it opens this thing. Oh, that's actually a sign message, not even a send transaction. That's the signature. Cool. Cool. I like it. Or I sign and send transaction 01 to myself. Yeah, whatever. This won't work because I'm not on DevNet. If I would go to DevNet, still not. Couldn't fetch network fee. If I confirm this, view this on Explorer, it worked. Phantom just didn't like it. 450 compute units. Cool. Reverted during simulation. That sounds like I'm not on DevNet. Whatever. Just Phantom being weird here. Cool, but I can already connect Solflare as well. Network mismatch. You're currently on mainnet, but this is DevNet. Yeah, there we go. That's Solflare is at least giving me that. Okay. And then here. There we go. Solflare doesn't seem to complain. With Solflare I can be like, send this, approve this. There we go. Cool. Yeah, I mean, it works great for the demo, but we're devs. We want to see how it works. Check that out. And I'm assuming that bman or whoever maintains the create Solana dep repository will also allow the new Web3.js once it's officially released. So most of that stuff should then work out of the box with that. So with the create Solana dep stuff. So there shouldn't be too much of a hassle with it, but let's have at least a little bit of a look of how it works behind the scenes. If I find the relevant parts. There we go. Use wallet account transaction sending signer. This thing takes the account and the current chain, which it gets from context chain context. And that thing itself comes from Solana React. So basically that is the important part. The use wallet account transaction sending signer, use wallet account transaction sending signer. We have a wallet account that is a transaction sending signer. Because with this one, we can't, directly produce the signature. We need to go through that wallet account. We need to open that pop-up, let the user click, and then we get the signature in our React app. That's why we have this use here, this hook, essentially. I don't know what it's called, but so that's all asynchronous. And then this transaction sending signer we can use. There we go. When we build such a message, we just create the message, we set the transaction fee payer, a lifetime, we append some, and then the interesting part here, sign and send with message signers. Hold on, wait, first, this guy comes in here. Yeah, so we set the fee payer. When we set the fee payer, we set that transaction message signer. And then also we can have it as the source here, because that thing holds the address. It's a signer. It holds the address. It's pretty cool, actually, yeah? And then that thing, the sign and send, here I assert that that is that. So here it would give me a true if I were to once again query if it's a transaction sending signer, which for me here, this one was not that key pair, but this here is. Assert this transaction message with a single sending signer. So it's only this guy is a sender. So yeah, for such a wallet adapter thing, we only want to give it that transaction if it's only one signature missing. In 98% of the cases, we just want to be the only one signing. So that's why we do all of those checks here. And if we want to do a partial sign, then we need to do it, differently. And Phantom and other wallets might just not allow that or display warnings if you try to do stuff like that. But anyway, with that method, with a sign and send, this also makes sure that there's only one transaction sending signer. So this assert is basically doing double checks. Like, it's not really relevant because this one does the check already now in the newest version, but it's good to have it in there anyway. We don't need to be super efficient in front end in TypeScript. It's not, doing another check like this, whatever, it's fine. Doesn't cost us more compute units. Client computer that has whatever. Not trying to be efficient or fast here. Yeah, so that's the transaction sending. Just signing a message is probably going to be very similar. We have the signed message that we get from a callback. Once again, we use wallet account message signer. Then we have the message signer to sign a message, modify and sign messages. Just gotta once see how that's done, and then you can just do it. But the more interesting stuff is like sending transactions anyway, like this. This here is the important part, such that this works and we get this thing from here. That's pretty much it. I mean, I would probably find it way more difficult if I had to build it myself, if I would build it from scratch. But I didn't set that as the goal, that I tried to do it purely by myself and struggle with it. Didn't want to blow up this video too long. Now is actually a good time to end the video because it's already late o'clock. So good time to end this video. Thank you for watching. Play around with it yourself. Now we reached the point where it's like you can pretty much do everything with a new Web3.js already. So slowly get used to actually working with it. Maybe not with an app in production that 100,000 people use. I mean, if you have 100,000 users, then congratulations. But even, not with an app that a lot of people use. But for just a hobby project for yourself, why not? Try out the new Web3.js. And do give feedback. As I said, now is still the best time to give feedback and actually change how it looks. And even just using it without that intention of, making the design better or whatever, just playing around with it and finding bugs like we did in one of the previous videos is also super helpful, because people will not want to migrate to the new Web3.js if stuff isn't working. And bugs can happen everywhere, especially in TypeScript. TypeScript is one of those languages, or JavaScript. It's one of those languages where it's like, how did that get in there, right? It's like, so I can understand how some things might just not work the way they're supposed to. But in order to find that out, you need to get to all of those edge cases, right? So we need to have a lot of people using that stuff to figure it out. So I do encourage you that you try it out, because eventually we want to all migrate to that anyway, and then slowly deprecate the old version. Even though I still like the old version, but the new Web3.js has all the functionality, is much leaner, and will be supported longer into the future. So we will need to migrate to that sooner or later anyway. Okay, and I'm already trying to make as many tutorials on that as possible, because the other stuff is out of date soon. This will also be out of date, but just because there's a new tech preview, or they will finally release it. I don't know when that happens, but I'm looking forward to it. And you can definitely expect me to make another video once it's finally officially released. Check out the one I made on the previous, the TP3, which has more of the basics on that new Web3.js. Some other video like this one. Subscribe if you haven't already. And then I will see you in my next review of the Solana Web3.js, which is really TypeScript, not JavaScript. Well, TypeScript is JavaScript, whatever.